Welcome to Safe Medication Dosage Calculations. Nursing is full of math, all kinds of math, so if math isn't your favorite, you better learn to love it very quickly. Block 1 math is the foundation of all nursing math, so it only gets harder from here. Get a solid foundation now, and each block will be less intense. The topics we will discuss are converting common household measurements to the metric system, military time, calculating intake and output, and dimensional analysis, and this is part 1 of a 2-part series. These are the objectives for today. We are going to accurately calculate medication dosage for the adult and geriatric patient using dimensional analysis. We're going to comprehend and apply metric conversions to household measurements, and we're going to convert to military time. Military time, also called 24-hour time, is the way healthcare uses time. Instead of saying 4 a.m. or 4 p.m. and possibly confusing which 4 o'clock hour we mean, we're going to use military time. Calculating military time is basically all of the AM hours are themselves, except for midnight, which is 0 hour. So we would call midnight 0000. 1 a.m. is 0100. 2 a.m. is 0200, etc. until we get to 11 a.m. or 1100. Once we hit to the PMs, that's when things start to get confusing. Noon or 12 p.m. is 1200, and then every PM hour after that is the normal clock hour plus 12. So 1 p.m. would be 1 plus 12 or 13, 1300. 4 p.m. would be 4 plus 12 or 16, 1600. We continue this until we hit midnight and the clock starts back over at 0000. This slide has a chart with all of the times as well as a clock face with both times on it. Back when I was in the nursing school, we didn't have smartwatches that can switch to military time, so I had to buy a watch that had the same face as that picture on the right. So when I looked down at my watch, because I worked 3 to 11, I could be like, okay, it's 10 o'clock, it's 2200. I'll say that smartwatches having military time is so much easier to help you learn military time. So as we begin to talk about some of the household or imperial system to metric or healthcare system conversions, we need to talk about the common abbreviations you'll see related to medication dosages. For length, we see inches, which is abbreviated IN, and centimeters, abbreviated CM. For weight, we see micrograms or MCG, milligrams or mg, grams or g, and kilograms, kg. We also see ounces as OZ and pounds as LB. For volume, we see milliliters or ml, liter or a big capital L, fluid ounces or FLOZ, teaspoons as TSP, and tablespoons as TBS. Now, if you noticed, and if you didn't, that's okay, all 3 of these tables have the empirical and metric system units of measurements. You will see that all of these get used, but when we document in healthcare, we document in the metric system, so we do have to know how to convert between the 2 systems. When we convert inches to centimeters, we have to do math. 1 inch equals 2.54 centimeters. If there are 12 inches in a foot, then each foot has about 30.48 centimeters. So how tall would a person who is 5 feet 5 inches be in centimeters? For me, I would figure out how tall the person is in inches first. 5 feet is 60 inches plus the 5 inches equals 65 inches. 65 inches times 2.54 centimeters equals 165.1 centimeters. Now try figuring out your height. So all electronic medical records, or EMR, require centimeters for height. The nice thing about EMRs is that most of them will either calculate it for you, meaning if you put the inches in, it will automatically calculate centimeters, or they have a built-in calculator that you can use to figure it out. We're used to weighing ourselves in pounds and ounces, but in healthcare, we weigh people in kilograms. So we have to know how to convert between the 2. Many medications in healthcare are ordered by kilograms, and by the time you get to block 4, all the drugs will be ordered and dosed in kilogram, so knowing the weight in kilograms is very important. Now, most hospital beds that have the ability to weigh, and most electronic hospital scales have the ability to weigh in both pounds and kilograms, and that makes life much easier for us. But if we don't have the ability to weigh in kilograms, then we have to do the math. There are 16 ounces per pound. So if we had somebody who weighed 150.5 pounds, that would be 150 pounds and 8 ounces. The 150.5 is just fine for converting to kilograms. But once you get into pediatrics in block 4, those actual ounces will make a huge difference. So pediatric weight is totally different. 1 kilogram weighs 2.2 pounds. So to find kilograms from pounds, we take the weight in pounds and we divide it by 2.2. So a 176-pound person divided by 2.2 would weigh 80 kilograms. In adults, we carry the weight out in kilograms to 2 decimal places, and then we round to the nearest tenth. So if we had an adult who weighed 205 pounds, we divide it by 2.2, that would equal 93.18 kilograms. Round that to the nearest tenth, which would be 93.2 kilograms. Now, you guys try to figure out your weight in kilograms. We've learned how to convert from pounds to kilograms. Now let's discuss how we weigh medications. So our medications come weighed in the metric system, which we call our medication dose. We can have medications dosed in kilograms, grams, milligrams, and micrograms. The nice thing about the metric system is it's based on 1,000, with kilo being the biggest number we used to micrograms being the smallest number we use. The difference between each measurement is 1,000. So 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. 1 milligram is 1,000 micrograms. To go from a bigger number to a smaller number, like kilograms to grams, we multiply by 1,000. If we need to go from a smaller number to a bigger number, like micrograms to milligrams, we divide by 1,000. If we need to calculate weights that aren't 1,000 apart, like if we're going from milligrams to kilograms, we can't skip a step at all. You have to do each step by multiplying 1,000. Trying to multiply by 1 million leaves way too much room for error with all those zeros, so you have to go each step by step. Just like with everything else, we use the metric system for volume. This is where things get a little tricky because a lot of normal everyday liquids, like what we drink, are measured in ounces. Some brands of drinks are nice and have both ounces and milliliters listed, which makes life very easy for us. So let's start with the hard numbers first. Fluid ounces, teaspoons, and tablespoons. 1 teaspoon, or TSP, is equal to 5 milliliters. 1 tablespoon is equal to 15 milliliters. 1 fluid ounce, which is the same as 2 tablespoons, is 30 milliliters. 2 fluid ounces, which is also a quarter cup, is 60 milliliters. And 8 ounces, which is 1 cup, is 240 milliliters. And 16 fluid ounces, or 2 cups, is 480 milliliters. When we look at milliliters and liters, this is another metric conversion that's based on 1,000. We have 1,000 milliliters and 1 liter. We use volumes to calculate liquid medication volumes and intake and output. Intake is how much liquid a person takes in, either by drinking or by intravenous fluid, and output is how much liquid comes out of a person. When we look at intake and output, we need to calculate everything that goes in and comes out of the body. Intake is everything that goes into the body, and this is going to include oral liquids, IV fluids, TPN feedings, tube feedings, liquid and GI medication, and ice chips. Ice chips are recorded at half the volume. So if my 4-ounce cup is totally full of ice, we're going to record that as 2 ounces of liquid because ice chips have a lot of air around them, and air is not a liquid. Output is anything that leaves the body. This would include urine, emesis, bloody drainage, liquid stool, nasogastric drainage, and anything that comes out of drains. The net fluid balance is taking the intake and subtracting the output. And this may be a negative number if they had more output than input. This slide is a reminder of decimal places. Anything to the left of the decimal is a whole number. Anything to the right of the decimal place is part of a whole. In nursing, we deal with tenths, hundredths, and thousandths place of decimals. We have some rounding rules we need to discuss before we get into how to do dimensional analysis in the next PowerPoint. First, unless otherwise noted for adults, which is all we discuss in Block 1, we're going to round all decimals to the 10th place unless we have a number that's less than 1. So if we have a number less than 1, we're going to round our decimal to the hundredths or 2 decimal places. We do this by looking at the 3rd decimal place or the 1,000th. If the number in the 1,000th place is 5 or higher, we're going to increase the number in the hundredths place by 1. So if the number is 0.815, we would round that to 0.82. If the number in the thousandths place is less than 5, we're going to use the existing number in the hundredths place. So 0.784 would round to 0.78. If our number is greater than 1, then we're going to round to the nearest 10th decimal place. To do this, we're going to look at the number in the hundredths decimal place, and if that number is 5 or higher, then we increase the tenths place by 1. So 5.78 would round to 5.8. If the number in the hundredths place is less than 5, we're going to use the existing number in the tenths place. So 6.21 would round to 6.2. We have some other decimal rules that are musts, meaning you will do these with each question or the question will be wrong because it is a safety issue. First, we do not have naked decimals, meaning we do not have any decimals that just start with that decimal point to start the number, like 0.25. If we do not have a 0 before the decimal, like 0.25, then 0.25 can easily be misunderstood as 25, which would be a major issue if we're looking at medication dosages, and this would kill a person. The next decimal rule we have is never have a trailing 0. We would never put a 0 at the end of a whole number like 25.0, as this could be misunderstood for 250, which would be a major issue. Also, we would never put a 0 at the end of a decimal. For example, 25.420. We would just leave it as 25.42. Like I said, these are major issues and these could kill people, so it's very important for you to know and follow these rules, and you will miss points on your math exam and your math questions if you do any of these. This is the end of the first part of safe medication dosage calculation, and our next PowerPoint is going to focus on dimensional analysis.